There is a monkey here in a tree. Very happy. And here is a hunter who never took 801, and he has a gun which is a golf ball gun, and he aims that gun right at the monkey. He shoots it with a certain velocity, the golf ball. Let this be the speed, v0. So the horizontal component, you're going to see that again and again, v0 cosine alpha, and the vertical component equals v0 sine alpha. Let this be my increasing value of y, and this be my increasing value of x. This golf ball, this golf gun, is really not first class, thank goodness. And so, when the hunter shoots this golf ball, this happens. And it ends up here at point P. Lucky monkey, so far. Now, it is very tragic, but true, that when the monkey sees the flash of the gun, it lets go. And now comes the question, is the monkey safe, or is this the last day of the monkey? I asked the following question. This would be the trajectory with no gravity, and this is the trajectory with gravity. We can both agree on that. At a certain moment, t1, let us assume that the golf ball would have been here without gravity. Then I know exactly where it is with gravity. It must be exactly here, because the x position, xt1, is the same because the horizontal velocity is the same. That's independent of whether there is gravity or not. There is no acceleration in the x direction. And so, they are both exactly at the same x position. What is this difference? Well, that is the difference between the equation with gravity and without gravity. And y, as a function of time, you can look at equation number 3 there, if you can still see it, equals v0y, which is v0 sine alpha, time t, minus 1/2 gt squared. Well, if there is no gravity, this term doesn't exist. So that's this straight line. With gravity, it's the same thing, but you have to subtract this. Therefore, this distance is 1/2 gt1 square. That is this distance, because this curve is lower by this amount. Now comes the time that the golf ball hits point P, when its position is xt2, and the time here is t2. That means if there had been no gravity, the golf ball would have been there. They must have the same position in x at this catastrophic moment. So what now is the distance between the monkey and the golf ball, the distance between the two trajectories, one trajectory no gravity, the other with gravity. This distance equals 1/2 gt2 squared, for that same reason. And we all know that if the monkey at time t equals 0 let go, that in t2 seconds, it will have fallen exactly over a distance 1/2 gt2 squared. Exactly. This couldn't be more tragic. And he will be killed. You may say, well, yeah, but you have manipulated the speed of that gun just so nicely. Oh no. Oh no. I can shoot that with a higher speed at the same angle alpha, and the trajectory would be this, and the monkey would be killed there. I can do it with a lower speed, and the monkey would be killed here. It's independent of the speed of the bullet. Because always this part here is always exactly the distance that the monkey falls in that time. However, if the speed is very low, that it hits the ground before the monkey hits the ground, well, okay, then the monkey is safe. So the only thing that is very, very critical is alpha. It must be precisely aimed at the monkey. If that's not the case, then the monkey will be safe.